Okay, let's take a look at this question. So we have y equals to a minus b cos 4x minus half sine 2x. Then you have d2y dx squared plus 4y equals to 3 cos 4x plus 1. Find the value of each of the following constants a and b. So if you differentiate it, you will get this guy. Okay, fine. Then differentiate the a, you get a constant. Differentiate negative b cos 4x, you get negative b multiplied by derivative of cosine, you get negative sine 4x, 10 times the 4. Then here you differentiate negative half sine x, you factor out the negative half, differentiate the sine, you get cosine, you get 2x, and then differentiate the 2x, you get a 2. Okay, good. Then after that, you can multiply negative with negative gives you a positive, then 4 times b gives you 4b times sine 4x. Then after that, you have negative half times 2, that cancels away to give you negative 1 times the cosine 2x. Okay, good. Then d2y dx squared, this one just have to differentiate another time. So if you differentiate 4b sine 4x, you end up with just the 4b, but you differentiate sine 4x, you get cosine 4x, but differentiate the 4x, you get a 4. 4 times 4 gives you that 60. Okay, good. If sine, leave it alone first. Differentiate cosine 2x, you get negative sine 2x. Then you differentiate the 2x, you get a 2. So negative gives you positive. That's how you get the answer here. Okay, good. Can. Then over here, you're given that this guy equals d2y dx squared plus 4y equals to whatever. So all you need to do is to substitute in, right? Okay, d2y dx squared is this guy, substitute in. Then plus 4y, so 4 times of y. But what is y? Y is over here. Oh, sorry, this whole thing, right? Just replace it in. And this will be equals to 3 cos 4x plus 1. Okay, good. Then from there, you can distribute the 4. Let's see, 4a minus 4b cos 4x. 4 times negative half gives you negative 2 sine 2x equals 3 cos 4x plus 1. Okay, good. Good. Then after that, you just try and simplify a bit more. So we have a plus 2 sine 2x minus 2 sine 2x. They cancel away. And then you have 16b cos 4x plus a 4a minus 4b cos 4x. Okay. So here, because of the 16b and the minus 4b, they simplify into 12b. Okay, good. And then you have a plus 4a. This is equal to 3 cos 4x plus 1. Okay. Don't put the extra equal sign there. Next, you have 12b cos 4x plus 4a equals to 3 cos 4x plus 1. Okay. Then from there, you can just compare, right? The coefficient of cos 4x is 3. Coefficient of cos 4x is 12b, so therefore 12b equal to 3, b equal to 1/4. Good. And likewise for the constant, 4a equals to positive 1, so divide by 4, and you get a equals 1/4. Okay?
Okay.
Okay, good. That was that question 3. Okay, how about the other questions? Let me see. Question 3 onwards, question 4 onwards. Okay, let's see. So I marked this halfway. So what we ended up with, okay, this question 4 is okay. This question 4 is okay. Nothing to discuss. You got it right. Question 5 as well. Question 6, not so good. The explanation. Let's take a look. A virus was spreading at a chicken farm such that 2% of the chickens were infected in one day. Infected chickens were culled daily. If n is the total number of chickens before the start of the virus infection, assuming that the virus continues to spread at the same rate, explain why the number of chickens expected to be alive after n days is given by 0.98 power n multiplied by the initial population, capital N. Why? This.
What chapter is this? Like I
what
know.
chapter? Exponents.
Yeah, okay.
Power x. The e power x topic, right? Applications, the applications part. Before we started logarithms. Okay. So what you need to elaborate more on is how do you link the 2% here to 0.98? So a simpler explanation would be you start off with 100%. Then if you 2% get infected and they are culled daily, mean they are killed. Okay. So that means you have to subtract away 2%, right? This gives you 98%. Okay. So you can think of it as remaining percentage. Maybe here's one way to present it. Remaining percentage equals 100 minus 2, which is 98%. Okay, to present it nicely, equal sign along the same column. So 98%. But wait, what's 98%? It's just 98 divided by 100. Oops. Just why is my highlighter not showing? Okay, this one equal sign along here, then 98% is really just 0.98, right? Okay, good. So that means that 98% is left after each day. So that means that after one day, exactly what you wrote over here, 0. Okay, I don't have to rewrite it. You already wrote it. After one day, then you're left with the original population multiplied by that 0.98. After 2 days, then it will be power 2. If it's after 3 days, then power 3, so on and so forth, until if it's n days, then it will be power n. Okay. So after n days, remaining number of chickens is equals to 0.98 to the power of little n times capital N. So one here changes to an n. Is that okay? Okay, good. So how about part 2? Let's see. It is known that the virus will infect X% of the chickens in 7 days. Calculate to the nearest 2 significant figures the value of X. Okay, your answer is fine. The concept, I get what you're doing. So what you're doing is you replace the n with 7, right? Because after 7 days, then this will give you the remaining percentage of chickens multiplied by n, right? Remaining percent of chicken multiplied by n, which gives you the remaining number of chickens. Then if you take the original number n minus away this remaining, that gives you the original, the number of chickens that died, right? So in this case, that's really just 0.132, which is 13.2% of n. So that means that it is equivalent to this X% of chickens that got infected and were then culled and died. Right? The moment you get infected, you're culled. So that's one way to do it. But if you want to do it using algebra, here is another way, in case you want to know. It is known that the virus will infect X% of the chickens, right? So if, let's say we start with 2%. If 2% dies, that means that you have 100 minus 2, which is 98% of all the n chickens remaining. Or in other words, 100 minus 2 over 100, which is the 98 over 100, multiplied by the original number. Is it okay so far? So now if I just change the 2% to X%, I just have to replace everywhere there was a 2 with an X. So it's 100 minus X over 100 times n. Okay? This will be the remaining number of chickens. Okay?
Okay.
Right? But we have another formula for the remaining number of chickens, which is whatever you calculated over here, 0.98 power 7 times n, right? From part 1. So that means that we can equate these two, 0.98 power 7 times n, as well as 100 minus x over 100 times n. I just copy and paste it over here, right? So these two are two different ways of expressing the remaining number of chickens. Then from there, you can solve for x, because you can divide by n on both sides. The n cancels away. Then from there, you can solve for x. Okay?
Okay.
Can? Yeah, that's another way if you want to use algebra. But your idea is also okay. For part 3, part 3 is fine. Yeah, there's nothing to say. Just equate the formula to whatever they gave you. That's the equation, n times e power kn. Then from there, solve for k. You got it. Okay, next one, question 7, binomial expansion. One slight mistake over here, which is 5 over x to the power of r. You are supposed to rewrite it as 5 power r times x power r. Okay, like this. Correct? You sure it's working? Which means that you can also rewrite it as 5 power r times x power negative r. Right? Okay, so you're missing a power r on 5.
Okay.
Right, that's the only mistake. Can? Good. Then part 2 is fine. You just have lucky for you, for the power of x, it's just n minus r. So n minus 2r after you simplify. So it doesn't get affected by the 5 power r. Okay? Right, good. Then from there you solve for n equals to 2 times r. So it's a multiple of 2, which means that n is even. Okay. Good. Next one, part 3. So now you want to have a power 6. You just have to take the power here, which is your n value, substitute in, and then equate it to what is the desired power. You want power 6, right? So just equate it to power 6. Right? n minus 2r is over here, you equate it to power 6. Then from there, solve for r, sub in, and you get the answer. Very good. And next, how about part 4? Part 4 is a little bit more special. Hopefully you realize that maybe I already used yellow and blue. Let's use green. You already know that you have x plus 5 over x to the power of 10, right? Which looks very familiar. Where do you see that?
The previous part.
From part 3, right? So let's just label there part 3. So that means you have to use the answer from part 3. Oops. You have to use the answer from part 3, okay? So let's see. You have x power 6 already. They gave you a hint in part 3. Find x power 6. So definitely you have to use it, right? Probably,
Yeah,
not
for sure.
definitely, They say hands up. But yes, in this case, you indeed have to use it. Because what they're asking for is the coefficient of x power 6 in the whole expression, right? So the whole expression is not simply the green color highlighted part. Instead, it is the green color highlighted part multiplied by these two terms here, right? Multiplied by these two terms here. So what you need to do in order to get x power 6, if you already found the x power 6 term, which are highlighted in blue from part 3, you just need to multiply it by the constant -1, right? Then from there, if you multiply these two, you'll get your x power 6, one such power x power 6. Is there another way? It's already there, huh? Is there another way?
Or
Yes.
as in like to get x power 6.
Yes. Instead of just blue times blue, you need the yellow times the yellow, right? You need to find x power 4 from this the green color expression, which is the x plus 5 over x power 10, and multiply by the ax squared. Then from there, you can get your x power 6. Okay?
So besides these two, besides these two terms, there's no other terms I need to care about.
Will there be any others?
I mean, okay, now that you say it, right, where it's like just times this and this, like, I don't think so. But when I was doing this, that's what I thought. Like, I thought it wasn't just those two.
No. It will only be these two. It will only be these two. Now you can check with let's just say with a quick example not the exact expression for the green, because there will be 11 terms, a bit too long-winded. Let's say instead we go for something like I don't know, what's a good example? Let me think. Let's say x plus 1 power 3. Then this will be, if I ax squared times x plus 1 power 3, this will become ax squared minus 1, but you multiply by x cubed plus 3x squared plus 3x plus 1, right? Then let's think about it. How do you obtain, in this case, maybe, for example, x power, let's see, maybe we want x power 3 term, the coefficient of x power 3 term in this.
So it would be this one and this one.
Okay, that's one pair.
This one and this one.
And yes, the power 2 and the power 1, right? So that's the only way, right? Is there any other?
No, there's no other.
Oh, sorry. Should be power 2 with power 1. Highlight wrong. Oops. Yeah, that's so that's the only way. Only
Okay.
So same idea here, but with power 10. So yeah, there won't be any others. Okay, so here is the procedure. Step 1, you go and find the first. You need to do this. Actually, this is step 0. You need to realize that you need x power 4 and x power 6. Okay, you need the yellow color and the blue color term. Then after that, step 1 is to find those x power 4, x power 6 terms of this expansion, of this binomial expansion. Then after that, in step 2, you need to multiply the ax squared, the yellow one, with this term that you found, the x power 4 term, with a happy face. Maybe I highlight in yellow. And then after that, you multiply the other blue color term, the -1, with the sad face. The -1 here, multiply with that other expression, other term. Okay. Then from there, you multiply already, you get x power 6 for the first one and x power 6 for the second one, add them together, and you get your coefficient for the x power 6. Do you need me to show you?
No, I can do this.
For power 4, you just need to work it out on your own. N minus 2r equals to 4.
10 minus 2r.
10 minus 2r, sorry.
And find r. Then sub r into the general thing.
Yeah, the general formula.
And choose r. Then actually, and choose r, and A, is it N minus R, M B R? No, wait.
Yes, that's it.
Oh,
This
okay.
is this term, is it the R term or R plus 1 term?
This is the R plus 1 term.
Very good. Then must always be a plus 1 because our R starts from 1. Okay. Sorry, no, our R starts from 0. Oh my goodness. TR plus 1, R starts from 0. Okay, so 0 plus 1, that's how we get T1, first term. The counting of the term starts from index 1. So the R must start from 0. N choose 0, N choose 1, N choose 2. Okay? Then you do on your own now.
Okay. Can.
Okay, good. Next one, question 8 is fine. Very, very good. Follow the Desta procedure. Differentiate equals 0, solve for x, draw a table if you need to prove that it's nature. Here, okay, you also show that 2r equal to x. So it's fine. You also managed to show it's a minimum point without drawing a table. Very good. Use second derivative test. Good. Here you have okay, part 1 is fine.
Oh yeah, this is the one I sent you.
Yes. Sorry, I haven't had enough time to send it back to you. For part 2,
you
there
did.
was a I did. Oh.
Yeah, for part 1, because I sub like the lines that were not intersecting, and then I was like, why is it not?
Oh right, I remember now. Yes.
Then that's why I could.
That's why you couldn't solve it, right? Yeah, we have to find the lines that are intersecting to solve.
Yeah.
Using the long lines.
Then I said you could sub into each either one of the lines, but then I think only point B is only like these 2 lines that you can sub in. Then okay, now yeah.
Yes, correct. So you should only be using line AB and line BC. No other possible pairs of lines. Okay, not either one. Yeah. So anyways, part 2 here you need to understand the English here. Okay, it's English comprehension. Here they say the point E lies on the line DA produced. When they say it this way, D and A produced, it means D to A, and then you produce in the same direction. So the point E is actually outside. Yeah, that's why you couldn't solve it.
Yeah. Okay, produce. Okay.
D, A, produce. You start at point D, go to point A in the same direction. You extend out until you hit until you get a point E.
Then because the height is the same, so then the base.
Ratio of the area is the same as the ratio
of the base. Wait.
Yes. So okay, I don't even need a comment anymore. So therefore, what you're supposed to conclude from this hint given to you is that the base of triangle BED, which is, can you tell me what's the base?
The base of triangle BED.
They share a common green color height here. Common green height. Okay, the common green height. So what is the base of triangle BED?
BED. BED is just ED.
Right. So therefore, I can replace it with ED over. Oh. Okay. Yeah. Oh, wait. Okay. Yeah. Just replace it half times H times H. Then divide by what's the area of triangle? Yeah.
So it's just ED over AD equals to 4 over 2.
Very good. Okay. So this is a trick. You should try, and if you want to do it faster, then you can remember. Whenever you have 2 triangles that share the same perpendicular height, right? Then you just need to compare the ratio of their base, because the half and H will cancel away. Okay, we'll just move down, give you a bit more space. Yes.
AD is can find because they give you point D and point A. Then after that, you can just find ED.
Yes. This one just use distance formula, length formula. How about ED? What is ED? I've kind of.
Wait. Then how do you find point E?
How do you find point?
You have point D and.
Do you remember the vector idea?
Okay. Wait. Okay. This one go up by like 9, and then here is go up by. Hey, wait, hold up. Here's go up by 6, and then here is go up by 9. So then this will just be the ratio. Wait, zoom out.
Okay, let me label the 6 and the 9 for you first. 6 here, 9 here. Okay, good.
It'll be wait, is it?
What information do we know from here?
It'll be one quarter of this and this.
Let's see. ED is worth 4 units. Okay, maybe I write it in ratio.
Yeah, ED is worth 4 units. EA is worth 1 unit.
AD is 3 units. So that must
Oh
mean
no, it'll be
EA is...
1/3 of this. Wait.
So wait, slow down. Maybe it's better if we just redraw the diagram a bit. Okay, so point E, A, and D, we just realized that ED is worth how many units? 4 units with a circle. AD worth how many units? 3 units. So how many units is EA worth?
One.
1 unit. Okay, from there we can tell that this triangle, okay, maybe I follow the same highlighting color. Yellow color triangle here and blue color triangle there. Ayo. Hold on, my iPad is lagging. Give me a second.
9 divided by 3 times 4. Then 6 divided by 3 times 4.
Wow, my iPad not behaving today. Let me... Sorry, can you give me a second? I need to reset the app.
Okay.
Okay.
Wait, why do we need the distance of the thing?
Let me see.
Wait, do we even need the
Maybe we
distance?
don't need it. Let's see. Actually, you know what? Yeah, we don't need it. We don't need it. Sorry.
Oh my god.
No.
6 over 3 times 4.
Yeah. So. Oops. Okay. Sorry. What?
6 over 3 times 4.
6 over.
dx coordinate. So 6 minus 6 over 3 times 4. 6. So minus 2 for x coordinate of d, and then wait, is it 7? Is e negative 2,7?
So you just need to scale it down. So you see, go from 3 units to 1 unit, you divide by 3, right? So the horizontal length here, 6, becomes scaled down by a factor of 3 as well, right? So 6 divided by 3, you get
2.
2 here.
Then you times.
Likewise for the 9. For the 9, you divide by 3, what do you get?
You get 3.
3. Okay, good. So from there, you can work backwards. What was your answer again? Sorry,
no.
Let me clear your drawing again.
Wait.
Let's think about it. How do you go from 6 to 0? You minus 6. So how do you go from 0 to
minus 2,7?
minus
Hey, yeah,
2?
I was right. I was right.
Right. Okay. So what's the y coordinate this time?
7.
Sorry. 7. Yes, plus 3. Okay.
Plus 4 plus 3. Yeah.
Yes. Okay, that's it. Point E is negative 2,7. Good. Okay. Can?
Yeah.
Moving on. Next one, part 3. Given that ECDF forms a kite in which FC is perpendicular to ED. So let's see. Where is point E, C, D, and F? Point E is here, C is here, D is here, and F is somewhere such that FC is perpendicular to ED. And find the coordinates of F. So from this drawing, this version, can you find out where is my F? I need a ECDF to be a kite. Can you plot for me a point? Yeah. How do I get? I need point F so that ECDF forms a kite.
Okay, no, that just looks like a square. I can't draw straight line.
Okay, I draw for you. But okay, you got the idea. Basically, you have this line here, 1/2, and then you have another half there, right? So That means your point F is probably somewhere here, roughly, approximately. It's not always directly below point E. You don't know that for sure. So you can just draw it a bit more to the side and then connect down like this. Okay, maybe, according to my drawing, it might be a little bit longer. Maybe here, like this, and then go down like this. Okay, something like that. Maybe like this. Roughly, yeah, roughly. Not very accurate. Okay. So how? Let's just plot that point F first. So let's read the question. So what other hints did they give you? ECDF forms a kite. Okay, I should copy down this diagram first. And I should also get a copy of the axis. Okay, wait, let me draw a quick copy of this diagram. Okay, so x-axis, point C, B, 90, A04. There's a y-axis origin. There's a point D, 6, -5. There's a point C is 5, 3, B is 3, 6. And you have a point E somewhere here, which we already found out its coordinates. I forgot what's the value. I'll look at it again. Sorry?
-27.
-27, okay, good. Is it showing?
It's actually not.
Oh no. Let me.
I think crash. Oh no, now I see.
I don't know. Why is it lagging?
Now I see it.
You see it? Okay, good. Good. Then I can bring it over. Okay, so anyways, what do we want? We want the point F, right? So probably somewhere on the graph, maybe here. Roughly, it's not accurate. E, C, D, and point F there. So what else? What other hints did they give us?
FC is perpendicular to ED.
Ah, very good. So that means that these two lines are perpendicular.
Yeah.
Then you want, as a result, from there you want to find the area of ECDF. ECDF.
Oh, this is so you find point F first, then you use this, the shoelace thing.
And the shoelace formula. So
Is
let's think about it. How do we find the point F? First thing is to remember the properties of a kite law. So kite is really just made up of two isosceles triangles. So maybe my point F, I want to draw it nicely. Looks a bit more accurate, if not a bit confusing. Okay, so point F here, 90 degrees there. So how do we do that? How do we find point F?
Vector.
Vector. How?
Yeah. Actually how?
Okay, let's think about it.
It's using vectors, but I don't know how.
Can we find out the point over here?
Yeah.
What do you think? What happens to this perpendicular line? What does it do to this FC here? It cuts it in half, right? So that means this is another way to describe it would be our midpoint, right?
Is this the midpoint of A and D? No, right?
No.
Okay.
What do you think? It should be a midpoint of which one?
Oh, E and D? Wait, no.
E and D, yeah.
No, I mean it's midpoint of F and C. But
F and C, yes.
But how you find it?
So how about we let the unknown F be known as A, B.
Okay.
When you don't know what it is, just call it F, A, B. Then how to find midpoint now? Remember the formula? Focus on this.
I mean A plus 5 over 2. And then B plus 3 over 2.
Very good.
And how do you find the midpoint?
Okay, then let's think about it. So
Okay.
is there another way to find out this midpoint? Which is this midpoint is a point of intersection between two lines.
FC and AD.
Can we find the equation?
Yeah, equation of AD have.
Good.
And then equation of FC. Perpendicular. So then if you do -1 divided by, or the negative reciprocal of the gradient of AD is the gradient of FC, then you can use a point slope formula, sub in x equal 5, y equal 3. And then you have equation of FC. Then you
Very
do
good.
equation of FC equals to equation AD. You solve for the point, so then you get like 2 points. Then you do a plus 5 over 2 equals to the x coordinate of the point that you solve, and then b plus 3 over 2 equal to the y coordinate of the point that you solve.
Very good. And then from there you can solve for A and B. Yeah, that's it. Okay, maybe I write down. Find.
How do you do the shoelace thing again? Oh my god.
Oh, okay. Well, this one down, minus up.
Down. No, wait, is x, y, x, y.
Yes,
no.
correct.
X, Y,
then,
X, Y.
Yes, then by diagonal down, I mean.
Down.
Product.
Minus.
The pairs are products.
Product minus.
Add them all together. Then minus open bracket. The product of the sum of the product of up.
Okay. And then
maybe okay, let me just write down the procedure, then you work it out on your own later. So LDE find first, then after that find L of FC. For the gradient, it will be -1 over m of the DE. For the point, you will use point C, 5, 3. Okay. For part 1, for finding LDE, I think you know, you are given 2 different points already. You can definitely find gradient and point slope formula. Then for number 3 is to solve 1, 2, just equate them, right? Y equals, and you can equate them. So therefore, you can solve for m. X, y. But m can also be the midpoint formula, a plus b over 2, b plus 3 over 2, and then you just have to equate. Okay, let me just write this down. Use MPF, midpoint formula. Then you get m. Okay, copy and paste. A plus 5 over 2, b plus 3 over 2. Then from there, you can just equate them together. Curve equals not very accurate, but okay, you get the idea. Right, from there, solve for A, B. But wait, not done yet because that's only point F, right? Then later you need to find area of B, C, D, F. So just a quick recap on shoelace formula. So for example, let's say, I don't know, maybe this is 1, 5, this is 2, 4, this is, okay, maybe I change this to a 3. This is 2, something a bit lower, 3. Okay, like this. Then find the area of this figure. How? Shoelace formula tells you, you start with half, you put a pair of modular signs. Then you put x, y, 1, 1, x, 2, y, 2, x, 3, y, 3, x, 4, y, 4. Because there are 4 points, so you put down up to, you put down until y4, but you must add on 1 more point, x1, y1. Okay, then it's down, minus up. What does that mean? It means if I just use the actual points now, so area of the figure is half times modulus. Here's a good point 0, 0. So I'll just write it as the starting 0, 0. Then after that, you must go either clockwise or anti-clockwise. The modulus sign will help you to make sure it's positive, but going anti-clockwise will guarantee it's always positive. So let's just go anti-clockwise. So anyways, 0, 0, 2, 3, 3, 4, 1, 5, and then finally back to 0, 0. And then the lines are just for aesthetics, don't really need to draw it. So next you have half times. Here is how you calculate this. Down, right? So that means the downward pairs, you're gonna take the product. So 0 times 3 plus 2 times 4 plus 3 times 5 plus 1 times 0. That is the first term. Then you subtract. Okay, I'm running out of space. Let me see. Bring this down, bring to the side, bring a minus over, open a bracket. That's my down, down, down. Now I need up, up, up. What's up, up, up? Means you go this way. Okay, so you minus away 0 times 2 plus 3 times 3 plus 4 times 1 plus 5 times 0. Do you know where I'm getting these numbers from?
Yeah.
Yeah, 0 times 2 goes here. Then the next blue diagonal, 3 times 3, up, 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 goes there. The next up is 4 times 1, it goes there. And finally, 5 times 0, it goes there. Right? Close the bracket, and then just type the whole thing in the calculator and you get the answer. Okay? Oh, sorry. This is not square bracket. It should instead be modular signs. Modular signs to make sure it's positive. Okay? Shoelace formula?
Yeah.
To find area. Yeah, you just apply it in this case after you found the point. Sorry, after you find the point F. Okay, good. Okay, no more questions?
No.
No, moving on. Next, this one, kinematics. Haven't go through yet. Go through soon.
Okay.
Next one, question 11. Given that fx, we'll see if we have enough time. I'll go through kinematics later. Okay, so question 11. Let's see. It's given that fx equals 2 minus 3 times sine of 3x and gx equals 4 times cosine x over 2 minus 1. State the least and greatest value of f of x.
Okay, I mean, I know sine x it would just be like 1 and minus 1.
Good. How about 3x?
But
Sine 3x.
Okay, then it would be 3 and then minus 3.
No. I meant sine of bracket 3x. Does that affect the max?
No, it's same. 1
Same,
and minus.
Okay, good. Then what do we actually have?
Oh, I mean, you have minus 3. Then
So
will not be 3 and minus 3.
yes, correct.
Okay.
And then continue. But you also have
2. So it means you plus 2. And then, okay, this is where I'm like, because I remember you saying something about like, if there's plus 2, then it's like easier to, or you do less work or something. So that is easier. So
okay, that one is on horizontal transformation. What you're thinking about is the example where I was talking about an example like, for example, okay, I use FG, okay, I say h of x equals 1 over x. Then I change it to h of x minus 2. Technically not in the syllabus yet for AMAX, but you're going for engineering, I'll just tell you straight away. So x minus 2 here means that you're going to translate 2 units to the positive x direction. Okay, think of it like, because there's somebody pulling you down, pulling 2 units down, then the x has to work harder by 2 units. So that's why it has to shift rightwards 2 units. So originally
so
1 over x.
Does that work for inside here? Like, if like this?
Yes, it does. If it's sine of bracket 3x plus 2. So that is known, that thing here, the x replacing with x minus 2, that position there is known as the argument of the function. Okay. Technically, you haven't learned about function notation, so telling you about this may be a bit extra, but I want to let you know, when it's inside the brackets, minus 2, then you have to move rightwards. So just a quick sketch of this graph. 1 over x looks like this, whereas 1 over x minus 2 looks something like this. Vertical asymptote x equal to 1 versus vertical asymptote x equal to 0. Y-axis, x-axis, origin, y-axis, x-axis, origin. Okay?
Okay.
Yeah, but here, is that the case?
This is my answer, by the way.
Oh, sorry, you already did it. Oh, plus 2.
No.
Yes, exactly, that's it.
No,
5 to negative 1.
Because I'm not sure. Then I'm like.
So maybe a neater way to present this work, to present whatever you are doing just now is the following. Sine 3x, right? You can trap it in between two values, negative 1 and positive 1, equal, right? Using inequality notation. Very, very neat and tidy. But make sure that the smaller one is on the left, negative 1. Then you times negative 3 to the sine 3x. What happens to your inequalities? When you times negative, flip it around. Right? Then times negative 3, so this becomes minus 3, this becomes positive 3. And then after that, you plus 2, so you add 2 to all three sides of the inequality, you end up with 5 more than equals negative, let's see, 2 minus 3 times sine 3x more than equals negative 1. Okay. Yeah, so therefore, this is minimum, that's the maximum. Okay, how about g of x? Sorry, let's see, you're working cosine, good. The x over 2 doesn't do anything, times 4, okay. Oh, how come your inequality flip around already? You only flip it. How come it's negative 4 on the right and positive 4 on the left?
Oh, whoops. Wait, ignore that. Wait, hold up.
Negative. Much better. Good. And then minus 1. Good. Yes. So negative 5 and 3. Okay. You copy the working on your own. Okay. Next one, period.
Is it not 120?
Yes, exactly. As simple as that. Right.
Then for the other one is 720.
Divide by half. Times 2. 720. Yes.
Oh, okay.
Okay, think of it like 360 degrees divided by a half. Right, divide by coefficient of x. So we end up with 360 degrees times 2 or 720 degrees. Or another way to think about it is cosine, you are trying to draw the graph of cosine x over 2 minus 1. Remember what I told you about the coefficient, right? From 0 to 360, the coefficient tells you how many pieces of the original graph you'll see. So for cosine, it's down, down, minus, down, down, up, up. But here you have an extra half factor. That means you only get the left half from 0 to 360. Down, down. Don't have up, up. So to get the full curve, you will need to extend up and up, which means it goes until 720. Double the length. 360 for the first half, another 360 for the second half. So 720 degrees. Is that okay? Can I? Yep. Okay, that's a period. How did they ask you to sketch? Let's see. Yes, they did. Sketch on the same axis, y equal f of x, y equal g of x for x between 0 to 180. Let me copy the equation first so it's easier to discuss this. Okay, let's take a look. How? Okay, let's summarize some of the information we got from the previous parts. So we already figured out least and greatest values for f of x, 5 and negative 1. Negative 1 and 5. What about g of x? G of x, the least and greatest is negative 5 and 3. Okay, good. Then let's draw the sketch now. How to draw?
Okay.
Take note of the max and the minimum. 5, negative 5. You need to go until negative 5. So your x-axis. Good. Mid value. Which graph are you trying to draw first?
FX.
Okay, let's think about it out. First, you must find the mid value, right? The mid value. What is the mid value? Minus 1 plus 5 divided by 2 is?
Wait, I mean it's 2.
It's 2, not 3. Were you listing the maximum value for the other graph?
No.
Okay, yeah, so find the mid value first, which is the positive 2. So draw that dotted line. Then your graph will go above and below this midline. Let's focus on one thing at a time, f of x. Let's draw f of x first. Okay, so what was the period again for this guy?
We did 360. I mean 120.
120 degrees. So that means that you'll see the full graph in 120 degrees. But they asked for 0 to 180 degrees. which means you have to plus another 60 degrees. So 60 degrees is half of that period, 120, right? So that means we'll have half of that graph. Yeah, okay.
Assume that this is 5.
Yes, good enough. Can. Very good. Okay.
And mid for the other one, 5 minus 3
Minus
divided by
5.
2. Oh, I mean 3 minus 5 divided by 2. -1. -1 is the mid
value.
Yeah, mid value -1.
Label a 2 on the y-axis.
Oh.
Yep, good.
And then cause 720 for the full thing. So 180 would be like, is it 1/4 of that?
180. Let me wait. 180.
It'll be 1/4.
Yes.
Yeah, it was 1/4. So you only see the first part.
Yes. So down, up, you only see the first quarter. Right.
It's like,
the first one? Yeah, so
but that's so like weird to draw.
Just go down. Don't have to be super accurate.
But like
this one is not drawn to scale.
Okay.
So maybe it's good if you label 180 mark on the x-axis. Where is the 180 degrees on the x-axis?
Here is the 180.
So that same broken line, you must continue all the way down, and it must hit the -5, right? 180 degrees, comma, -5. The g of x, when x equals 180 degrees, the g of x is -5.
So be here.
You have the point there. Yeah. So yeah. So you're drawing. Try again. Downwards. Yeah, something like that. Then as to whether it will intersect with the original graph or not, like at the corner here.
Fx equal g.
Yeah. That's the only way. But I don't think that's the point of the question. You don't have to worry about it. Okay. Wait a minute. Let me take a screenshot. I'll send it to you. Then you can just copy it if you want to, or just redo the question. Okay, sent already. Can you want to see the exact graph on Desmos?
Okay.
Yeah, let's do that. So let me share the correct screen first. Okay, let's type out the graph. So what we have is y equals to 2 minus 3 sine 3x. That's the first graph. And then we have another y equals, 4 times cosine of x over 2 minus 1, like this. Wow, why so many brackets? Let me make it look nicer. X over 2 like this. So we only need the graph to go from 0 to 180 degrees. So we can do the following: 0 less than equal x less than or equal to, here Desmos can only accept radians, so it must be pi over let's think, it's just pi, right? Sorry, 180 is pi. Then the other guy is 0 less than equals the same thing. I can actually copy and paste. Backspace, paste, like this. Okay, that's the graph. Let's see. Let me think a bit. What was the minimum value again? -1 versus -5. Oh, it's not -5. Let me calculate again. Oh, did I copy wrongly? Oh, it's not -5. Let me think a bit. This. Oh, might have miscalculated the least value of g of x. Let me see again. The least value of g of x. Let's see again now. So g of x is what? G of x is 4 cos x over 2 minus 1. Cosine is always in between
-1 and
negative
1.
1 and 1. So we times 4 first.
Okay.
So we end up with positive 4, negative 4. Then we subtract 1. We end up with 3 and negative 5. Right. Right. Did I type wrongly in the decimal? So let me double check. Oh, I forgot. No. Hold on a second. Right, the domain issue. Oh, right. Okay. Here, it only hits the -5 at when does it hit the -5? Let's just draw the full graph. It's all the way to 720 degrees. Then it will be down, down, up. Yeah.
Oh,
so
I
over
want
here,
to hit
180.
-5 at the 360.
Yes,
So we're going
correct.
to 180. So it will.
Correct. So we actually had to. Okay, let me move it a bit down. That's my mid value here. Yeah, so actually 180 only hits until -1. At 180 degrees.
Oh,
Okay.
okay.
Right. So the graph there needs to be edited. Okay, let's just draw it again. So like this. That's 180 degrees already. Then what we have, we got mid value is 2, so maybe somewhere here. That's 1, 3, 4, 5. -1, -2, -3, -4, -5, just to make it look a bit nicer. Then mid value was 2. This is 2 minus 3 sine 3x. That means we have, let's see, the period is 120. That means we need, oh, where's my minimum value? Hold on a second. -1 here. Okay. Down, down, up, up, down, and I think you need one more down, right? Okay, this one is my new 180 degrees. Like this, okay? Is that correct? Let me double check first. Sine. No. Oh my goodness, sorry. Sine looks like this. Negative sign looks like the opposite direction. Then after that, you move it 2 units up. Okay, so it should be from here until -1, down, up to 5, and down, and then down 1 time. Sorry, down 1 time and up 1 time until you hit here. This is 1 full cycle. This is half a cycle. Okay, good. Good. Okay, then after that, you have the 4 cos x over 2 minus 1. So in this case, because it is only up to 180 degrees, sorry, I was wrong here. No, g of x is not -5. G of x is only until -1. Okay, so it only actually goes from +3, which is here, all the way down to here. 180 degrees, comma, -1. This is 180 degrees, comma, 2. Okay. Yeah. That's my g of x. This guy is my y equal f of x. Okay.
Okay.
Okay, very good. Can. So actually, I didn't even need the bottom half of the y-axis. Okay, y here, x here, origin. Okay. Moving on. Okay. This one, circle. It's stop here because of the domain. Okay, for part VI, find the number of solutions to the equation, blah, blah, blah. How do we do that? So what we need to do is to link it to your f of x and g of x. So let's see. It's definitely something to do with the graph of f of x and g of x. Okay.
Okay.
Sorry?
Yeah.
Yeah. Okay. So let's figure this out. We already have f of x and g of x there. We got 2 times cosine x over 2 plus 3 over 2 times sine 3x. What do you think we could do to
I
get this
think
equation?
we can
You need to make this look like one of the f or the g functions.
sub fx equal gx.
Fx equal gx, okay. But okay, we can do that and see if we can somehow get it to be the same equation.
Bring the 4 cosine x over 2 to the other side, then bring the 1. I mean bring the 2 to this side.
Here I'll do a smarter choice because here there's a positive 2, here is a positive 4 already. If I bring over the cosine,
Okay.
so maybe I can just swap them around.
Makes sense.
Right. So, wow. Oh no, cannot copy.
Well, I always do that on my notability.
I don't know, there's a bug. They're not fixing it. Never mind, I'll write it manually like this. Then after that, what do you do? Coefficient is a 2, right? But here we have a 4. Okay. Good. Bring the sign over first. Also get 3. Good. Yes. Okay, you divide by 2 and you get the expression that's given. So that means that solving for the roots of this equation is equivalent to solving for the number of intersections between f of x and g of x, which is
3. Is it not 3? Wait.
Yes. That's let me actually double confirm. Yeah, it's 3. It's 3. Yes. Okay, if you go up, you can see it's 1, 2, 3. Okay, it's not exactly the x-axis. Sorry, my diagram not accurate, not drawn to scale. It's actually slightly below the x-axis. Yeah. Okay, let me try and make it a little bit more accurate. Oh. Okay, something like that. Okay, 3 different points. Yeah, so that's an answer to this question. Number of points of intersection equals to 3. Therefore, number of solutions is also equals to 3. Can? Good. Okay, next one. Question 12. Let's see what you do. Find the values of x and y which satisfy the equations. Equation 1, equation 2. Let's see. So 2 power x divided by 4 power y equals 1 over 8. 4 is actually 2 square, so it's 2 square power y, which is 2 power 2y. Good. And this is 8 is 2 cubed, bring up, become 2 power negative 3. You have 2 power x divided by 2 power 2y, which is 2 power x minus 2y. Same base, different power. You divide, you subtract the power. Okay, so you get x minus 2y equals to the power negative 3. Good. So from there, you get x equals to 2y minus 3. Okay, good. Then from this equation 1, you can sub in into 2. Right, so you get 9 power y times root 3 power 2x equals to 3 root 3. Here, what do you do next? You rewrite the 9 as 3 square and then power y, so you can multiply the power. Your root 3 is power half, then power half times 2 gives you just 1. Okay, my highlighter is not working. Square root here is power half, then you have a square here, so it's equivalent to 3 power half, then power 2x. Wow, the lag is very bad. Half times 2 cancels away. Come on, highlighter. Can you see the highlighting? Half and 2 cancels away. Good. Then you get 3 to the power of x. Okay, so 3 power x there. And this is 3 times square root 3, which is 3 times 3 power 1 times 3 power half, which is 3 power 3 over 2. Good. So you have same base, 3 different power. You just have to add the power. So it's 3 power 2y plus x. That means that you have 3 power something equals 3 power something. Just equate the power. 2y plus x equals to the 3 over 2. The power here and the power there are equal. Okay, good. Okay, so now you have equation 1 and 2, sub 1 into 2. Okay, so 2y plus x, which is 2y minus 3 equals 3 over 2. From there, you get 4y equals to plus 3 over, you get 9 over 2. Let's see. Yep, okay. Then divide by 4, you get 9 over 8. Yes. Sub y equals 9/8 into equation 2. Can. Either is fine, equation 1 or 2. Okay. Right. So you get 3/2 minus 2 times y, which is 9/8. You get -3/4. Let me see. Hold on. 6 minus 9, -3. Yes. Okay, good. Both are correct. Good. Next one, 12b. ABCD is a trapezium, area, blah, blah, blah. AB is that value, DC is that value, AD equals to BC. Without using a calculator, obtain an expression for the perpendicular distance between AB and DC in the form of A plus B root 3. Okay, can. So if we know the area of trapezium, we can just use the formula. So let's see what you did. Half times sum of the parallel sides, good, times the perpendicular height equals to that area. Simplify this, 8 plus 12, 20. Minus root 48 minus root 12 is minus square root 108. How do you get that?
Wait. How do I get what?
How do you get this square root 108?
100. Oh, you just multiply 48 times 12.
Oh no.
Wait, is that
Wait, hold on. Let me think of it.
No. I did what I do. Wait, is that what I did? Alright, minus wait, 48 is I use calculator, but I forgot what I do. I remember.
Yeah, it's correct. But wow, this one skip a lot of steps. Okay, so over here, maybe you can show a little bit more working.
Wait, what do you mean skip step?
This part, when you go from minus root 48 to minus root 12 equals minus square root 108.
Oh yeah.
Interesting. How did you get 108? Let me see.
I remember using calculator. Then I changed this thing to like this thing. You know what I mean? What's this called? You know when you 12 is 2 square times 3. I forgot what.
Prime factorize.
Yeah, I did that. Then I saw I forgot what it was. I don't know what. I know I did it like that way.
Okay. 108. Interesting. But okay, let me show you how I would usually do it. I'll prime factorize it or try to rewrite the base underneath the square root as perfect square. So let's say I can rewrite it as 4 times 12. Why 4? Because I can rewrite it as 2 square. Okay. So if you take a square root 48, it's the same as square root 2 square times 12, which is square root 2 square, then times square root 12. Square root 2 square, you get 2 root 12. Okay, so from there you get minus 2 root 12 minus square root 12, which becomes
this is why
becomes minus 3 root 12.
I just remember what I did. I typed square root minus square root 48 minus square root 12. Then I get like a whole bunch of decimal, but I press the square button. Then I get 108. That's what I did. I think that's what I did.
Oh, that's actually very smart. Wow, that's the same trick as evaluating sine 60 degrees, right? You get a bunch of decimals. Then you square both sides.
That's legit what I did.
And then you undo the square root. Right. Okay. Oh, I didn't think of doing that at all. Very clever. Very, very clever. Okay. Interesting. Oh, wow, the calculator is able to handle it. Okay, square and you get 108. Okay, but usually you would do it by hand like this. Try to get the square root to look the same. So in this case, square root 12. And minus 2 apples, minus 1 apple gives you how many apples? Minus 3 apples. Okay, but over here, you can also rewrite it as minus square root of 3 square is 9, then times square root 12, which is minus 9 times 12, 108. Okay, that's how you get it. Wow, no working, a bit confusing, yeah. But anyways, okay, all right, good.
Is this first?
Huh?
Is this search? Like what topic is it?
It's search, yes. Square root is search.
Oh.
Yeah.
I know that's search, but like the question is just search.
Yeah. They won't just ask you directly. They like to give a little application like area of figures.
Yeah.
Yeah, so over here, you rewrite it as 6 times root 3. Let's see if it's correct. 36 times 3 happens to be 108. So you can rewrite as square root 36 times square root of 3. If I can get my pen to load first. Okay. Okay, good. Like this, then square root 36 is 6 and root 3. Good. Then from there, you want to solve for what is it? Solve for the height h, perpendicular distance between A, B, and C, which is h. Then from there, you just divide. Then you rationalize straight away. Here you should have done something a little bit clever. I remember telling you this before. 20 and 6, any common factors?
Yeah.
2, so you get 10 minus 3 root 3. If you factor out the 2 first, then all you need to do to rationalize is to multiply 10 plus 3 root 3 top and bottom. This becomes a lot smaller. If you what you decided to do was 20 and 6, so there's an extra factor of 2, which is very big number. But if you can handle it, then it's fine. Okay, so a minus b times a plus b, what do you get? A square minus b square. So 20 bracket square minus 6 root 3 bracket square. You end up with 400 minus 108, which is 292. Okay, yes, the denominator is okay. How about the numerator? Let's see. So we get a plus b times a plus b. Okay, sorry, it's not a plus b again. It's c plus d, different. So you have to multiply term by term. First term, second term, 480, and then 24 times 6 is, let's see, 24 times 6 is 144 root 3. Then the next one is 22 root 3 times 20, which is, let's see, 22 times 20, 440, good. Then 22 root 3 times 6 root 3, 22 times 6, you get 132, root 3 times root 3 is 3, so times 3, you get 396. Okay, good. Then just add the like terms, 480 plus 396, you get 876. 144 plus 440 root 3, you get 584 root 3. Good. Then from there, you just have to split it up. It becomes 876 over 292 plus 584 over 292 root 3. Okay, good. This one you can remember. Multiply by the conjugate set top and bottom. Okay, 876 divided by 292, let's double check. Okay, you get a 3, good. And 584 divided by 292, you get a 2. Okay, very good. Your answer is fine. Very good. Okay. Oh, done. Okay. Any other questions you did? Yes. What is it? Xingli questions, all right? So let's see. 26. Okay, let's look at the figure. Figure A is in the figure A is the point of intersection of the curves y equals e power x and y equals e power 2 bracket 1 minus x. You want to find part 1, the area of the shaded region. Okay, good. So you just have to equate them together. The two equations, e power x equals e power 2 bracket 1 minus x. Distribute the 2, you get 2 minus 2x. This ends up being, if you take ln on both sides, x equals 2 minus 2x. So from there, you get 3x equals 2, x equals 2 over 3. Good. If you have x equals 2 over 3, you sub into equation 1, you get y coordinate of A. Then from there, what do? You get the coordinates of A 2 over 3 comma e power 2 over 3. Next, you integrate with respect to x to find the shaded region because you realize that it's just underneath this e power x, right? The upper minus lower. The upper is e power x, the lower is y equals 0. So you don't need to minus 0 because it doesn't do anything. So you just integrate e power x from x equals 0 to x equals 2/3. Good. Integrate e power x, my favorite function, you just get back the same thing. Don't need to do any work. Sub in the upper, sub in the lower. You get e power 2/3 minus e power 0. E power 0 happens to be a 1. Good. Next one, part 2. You want to find the area of that region bounded by the two curves and the y-axis, which is whatever you shaded in blue. So what you realize is that it's really just this area here, but subtract away this shaded region, right? Yep. Is that what you did? Let me see. You take integral of e power 2 bracket 1 minus x minus away e power x. Yeah, that also works. This is trapped in between these two functions, upper and lower function. So just subtract and sub in the limits 2/3 and 0. Let me see your working. So you get this minus this, okay. From there, you integrate term by term. Integrate this guy, you get back the same thing, but you divide by coefficient of x, which is -2. So negative there and 2. Okay, then I integrate this guy, you get back the e power x. Good. Sub in upper and lower limit. So what do you get then? Let's see if you typed it in correctly. E to the negative times a fraction e to the power of 2 minus 2 times x, in this case 2/3. And then minus e to the power of 2/3. That's the first term. I get a negative 2.9216. And then you subtract away, sub in with 0. So you get negative e power 2 over 2 minus e power 0, which is 1. Let's see what is this value. Minus e square over 2 minus away e power 0 is 1. This is 1. Okay, so we end up with minus away negative 4.694. So is this correct? So you add on to the negative 2.9216. You get 1.7729. Okay, it looks correct. Good. Yes. Okay, and then round off GSF. Can. Next one, question 27. Show that derivative of this guy equals to that guy, hence evaluate the integral over there. So this one, when you differentiate, you have to do product rule, right?
Yeah.
Keep one, differentiate the other, plus keep the other, differentiate one. Differentiate x, you get a 1. Good. Then from there, you differentiate this power half. So bring down the old power minus 1 to get the new power negative half. Then differentiate 16 minus 2x, you get negative 12. Good. Plus this other guy. Okay. Then you have negative power half, and then you have positive power half. Which one do you factor out? The smaller power, right? Oh, okay. Here you didn't do that. Instead, you rewrite it as a fraction. Also okay. So okay. So x on top, then this guy goes to the bottom. Then what? You have times negative 6, so it goes over there. And then you plus a square root something. Okay, so in order to add the fractions, you have to make what the same? Denominator the same. So you times top and bottom by square root 16 minus 2x. From there, you get the same denominator. Square root times square root, they will essentially become the square of that square root. They cancel away, you're left with 16 minus 12x. Good. Then from there, you add together, you get minus 6x plus 16 minus 12x, you get 16 minus 18x. Very good. So that is shown, right? Is it the same as what they want? Yes. Hence, you want to evaluate integral x over square root 16 minus 2x. So here, what you're supposed to do is write down the derivative equals to whatever answer you obtain as a first step. But okay, if you didn't do that, it's also okay, as long as you are able to integrate correctly. So integrate the derivative, they cancel away to give you back this guy. Then after that, you have to integrate this expression, but you split it up already. Did you do that? Let me see again. Oh, you are using the previous.
Yeah.
Okay. So integrate these two guys. Okay, can. Okay, good. Then from there, you get integral of the first term plus integral of the second term. When you integrate this guy, you can factor out the negative 6, right? Factor out the negative 6, then you get negative 6 times integral of x over square root something, dx, plus integral of the other guy, dx. Good. Then from there, integral and dx cancel away, you're left with x times square root. Then you have to continue. What do you do? What is the objective? You want to solve for x over square root 16, right? So integral. So this guy right here, you want to make this the subject. Good. Then you already have it, so you can just make this whole term the subject. What do? You left this alone, you brought this plus integral over to the left, so it becomes minus the integral. Good. So integrate this guy, which is linear power half. All you need to do is to use power rule. Add 1, get the new power. You get 3 over 2. Divide by the new power. So divide by 3 over 2 means times 2/3. Good. And then you have a coefficient of 12, negative 12. And you have to divide it because this is integration. Integration is the reverse of differentiation. In differentiation, chain rule is required. You need to times the coefficient. But here, integration, you work backwards. So you divide by negative 12, equivalent to multiplying minus 12 at the bottom. Good. This one leave alone. This one just factor out negative 6. Okay, can. Everything else still stays the same. Then this part you simplify. Let's see if you did it correctly. 2 and 12 cancel away, get 6. So negative 18, but minus becomes a plus. And power 3, then take a square root because 3 over 2. That is okay. Next one, we want to solve for the definite integral from 0 to 1. So you just have to divide by a negative 6 to the right hand side. Dividing by negative 6, if you bring it into the 18, you end up with negative 6 times 18, which is negative 108. And then you sub in the upper and lower limits, 1 and 0. Is it 5 over root 27? I'm not sure. Let's see. So negative 1 times square root of 16 minus 12 over 6. And then this other guy, 16 minus 12 is 4. 12 times 1 is 12, and 16 minus 12 is 4. Power 3, take a square root over 108. Then after that, you subtract away the other guy. Negative 0 times square root 16 over 6. This is just 0, so you can strike it off. Then minus away, sub in the 0. Square root of 16 minus 12 times 0, which is 0. 16 minus 0 is 16. Power 3, take a square root over 108. Okay, good. Can. Let's see if this simplifies to 5 over 27. So this equals to this, which is square root 16 minus 12 is 4. Square root 4 is 2. 2 over 6. Minus, this is square root of 4 cubed. Okay, here you can rewrite it as square root of 4 first, then cube the whole thing. Oops. Square root of 4 is actually 2, so it's 2 cubed, which then becomes 8 over 108. Minus, this first term disappears. Minus becomes a plus. This is square root 16 first, then power 3 over 108. But square root 16 is actually 4, so 4 power 3. Then 4 power 3 is actually 64. Okay, then from there you can type in a calculator. 2 over 6 minus 8 over 108. Or you could do it manually. But anyways, type in a calculator and you get, I got a 23 over 27. Did I calculate something wrongly? Right, I missed out a minus sign here. Whoops, sorry. Let me change that. Okay, let me type it again. So yes, I get 5 over 27. Okay. Sorry. Yes, your answer is correct. Good. Okay. Okay, good. Okay, next one, 29. Okay, so this one requires you to know the rules of the integration for definite integrals. Let's see, you have function f here, function g there. Given that integral of f of x from 0 to 3 is equal to negative a, so how do you interpret negative a? It means here to here of f of x. The area here is modulus of negative a, which is just a. Maybe, okay, it actually depends on, okay, a is positive constant. So yeah, definitely just modulus negative a, which is just a. Okay, the area here. Right. Here there's a minus sign followed by a positive constant a because this part of the graph is below the x-axis. Below must be negative. Okay. Likewise, for this other guy, integrate from 3 to 7 of f of x dx equals to b. That just means this area here is b. Maybe it's better if I label a here, b here. Then after that, integral from 0 to 3 of gx dx is equal to c. So where's 0 to 3? Here to here. Where's g of x? Is over there. Then you find the area under the curve above x-axis. This area is c. And finally, this part is d. Okay. So next one, you want to look at part A, expressed in terms of a, b, c, d. Integral from 0 to 3 of 2 times fx plus g, 3 times g of x. So what we have is this guy, which can be interpreted as 2 times integral 0 to 3 of fx dx plus 3 times integral of gx from the same, along the same limits 0 to 3 dx. Okay, good. So integrate from 0 to 3 of fx, you get negative a. So 2 times negative a plus 3 times integral from 0 to 3 of g of x is c. So did you get that? Let me see. Minus 2a plus 3c. Right? Here you have a modulus negative 2a.
Yeah.
Okay. No, you don't need the modulus.
Okay.
Because here the rules tell you that you can just split it up term by term. Okay, integrate term by term. And then you factor out the 2. So this is fine. Okay. Okay. Very good. So that is for 29 part A. How about part B? Let's see. Integral from 0 to 7. 0 to 7 of fx plus g of x. So integrate term by term here. Oh, actually you did it a different way. You split it up by a limit 3 here. 0 to 3, then 3 to 7. Okay, that's fine. Then after that, integrate fx plus gx from 0 to 3 means you can split it up as integral of fx from 0 to 3, then g of x from 0 to 3. So that gives you negative a and c. You don't need the modulus, okay? Don't need the modulus. How about the integral from 3 to 7 for fx plus gx, this part here? You split it as integral of the first guy plus integral second guy. Integrate fx from 3 to 7. That's this guy, which is b. Integrate 3 to 7 of g of x. It's this guy, so it's negative d. You don't need the modulus.
Wait, when do you need the modulus?
When they request for area. Area, then you need positive value. To get positive value, you need to use modulus. Over here, they didn't request for area. They asked for the algebraic expression, integral of fx plus g of x from 0 to 7. Okay? Yeah. So this is wrong. Oh, by the way, sorry, no. No. Yeah, just nothing to say. Just don't put the modulus. Just don't put the modulus. Leave it alone. Okay. For part C, now finally they're asking you for area. So that's when you really need the modulus. But the simpler way to interpret it is just to modulus it before you even begin. Interpret what this negative a represents. Negative a is just the negative of this area A here. So you just label that region with A. Accordingly, you also get B, C, and D. Okay, similarly, you also get the other areas. Then part C, the area of the shaded region, which is it? Let's see. So area of the shaded region will be integral gx minus fx and go from 0 to 3. Let's see. G of x is here, f of x is there. So upper minus lower, 0 to 3. That's fine, good. Then how about the other part? You take 3 to 7 of fx minus gx. Why? Because here is 3, there is 7. Who's on top? Fx. Who's below? Gx. Upper minus lower, fx minus gx. Okay, can. But actually, sorry, it's actually a lot simpler. It's just a plus b plus c plus d. Right? Because you get the total area under the whole thing. Okay, good. Next one, let's go. Okay, wow, what's this? Fine, the area, the diagram shows parts of the curve y equals sin x and y equals cos 2x. Find the area of the shaded region. So over here, can you just take upper minus lower, like sin x minus cos 2x?
Yeah, that's what I did. Wait, what do you mean? For what?
Like to find the area.
I feel
Like
like
you
that's
just, that's what you did? Oh, from pi over 6 to 5 pi over 6.
no. Right, no.
Let me see. Actually, no. No, it works. Yes, it's correct. It's correct. Yeah, you don't need to split into separate regions. This is, what was the value? Let me see your working formula. Sin x equal cos 2x, replace with 1 minus 2 sin square. So get a quadratic, okay. 2 sine square minus 1.
I'm confused about this.
Hmm?
Like,
Yeah, you missed out a square. You missed out a square. But anyways, let's see. Is it t minus 1?
I think I typed it with the square into the calculator.
Right. But you got the t correct though. T equal half and t equal -1. Then you just sub back in with sine x. That's okay. It's okay so far. This is the alpha. You should always find the alpha first. Alpha equal pi over let's see, 30 degrees 6. So
Yeah, when you have this, right, then how do you know what's the thing that you keep on you
adding the 2 pi, you mean? Or what do you mean? Sorry.
I don't know how to say. Yeah, if you have sine x equal half, how will you do it?
First step, find alpha. Second step,
Yeah.
look at the SIGN sign of the right hand side. Positive half. By the way, when you take sine inverse, you must always be positive already. If sine x equal negative half, you want to find alpha, you still sine inverse positive half. So sine x equal positive half. So which quadrant does it belong to?
First and second.
Good. So you find the angle in the first and second. So first quadrant is just alpha.
Pi
Good.
minus pi over 6.
Yes, correct.
And then the next round is what? Plus 360. I mean, plus 2 pi.
Plus 2 pi. You take these two answers, you plus 2 pi, plus 2 pi. Or you plus 4 pi. Alternatively, plus 4 pi.
Okay.
Or plus 6 pi. And also you can go backwards. So negative. Minus 2 pi, minus 2 pi. Minus 4 pi, minus 4 pi. Okay. Because you must understand that rotating 360 degrees is equivalent to taking this line, you rotate it 360 degrees. So you end back up at the same location. Okay. Yeah. Anyways, what were you saying?
Then for sine x -1. So for alpha, you just make it sine inverse 1.
No. When you have a +1, -1, and 0, my recommended strategy is draw the graph.
That's what I did. I erased it, but I drew it. That's what I did. No cap.
Okay, good.
I swear I drew it. I swear.
Okay. Yeah, so that's the correct way. I think it's also pretty fast once you memorize the graph, right? You can clearly tell straight away this is 270 degrees. Give you a -1. Okay, good. So you have to reject it, yes. Because here 270 degrees is, wait a minute, hold on a second. No. Wait. 5 pi over 6. Let me think again. Right, this is cosine 2x. This graph here only goes up to 180 degrees, right? It only goes up to 180 degrees. So 270 degrees is definitely outside of this region.
Yeah.
So that's why
I reject. Yeah.
Okay, good. Can. Then after that, your point of intersections is pi over 6 comma half, pi over 6 comma half. Okay, good. The half doesn't matter, so you just sub in lower and upper limit. Good. And then you give the integrand upper minus lower. That's fine. Okay, in this case, it's fine because the two roots, pi over 6 and 5 pi over 6. Over there is 5 pi over 6. They are bounded between they are bounding the shaded region. The shaded region is bounded between the pi over 6 and 5 pi over 6. Right? Okay. So yeah, and it bounded entirely. There's no sudden point that is a different function. So you can just take upper minus lower. Good. So integrate sine x, you get negative cosine x. Yes. Integrate cos 2x, you get sine 2x, but divide by 2. Okay, good. Sub in the 5 pi over 6 and pi over 6. Do you get that as the answer? Let me double check. To change to radian mode. Actually, no, I didn't have to do that, but okay. first half is 1.29903. Then the second half is subtract away. Okay. Just subtract away and I get minus away negative cosine of pi over 6 this time. Minus away sine of 2 times pi over 6. Divided by 2. And then I get 2.59807. Yes, correct. Good. 3SF then 2.60. Okay, Ken. Good, good. Question 33. Next one, show that derivative of ln cos x squared equals to negative 2 tangent x. Okay, let's see. So 1 over cos squared times derivative of cos squared, yes. Differentiate cos squared, you get power rule first. Bring down the old power minus 1 to get the new power 1. Differentiate cos x, you get negative sin x. Good. Cos cancels away. You're left with negative 2 sin x over cos x. Good. Sin over cos is tangent. Good. Differentiate 2x tangent x with respect to x. Let's see. So here you factor out a 2. There's a product going on. You use product rule, right? Differentiate x, you get a 1. Leave the tangent alone. Plus take the other, take the other, the x, then differentiate the other guy, tangent x. So this becomes 2 bracket tangent x plus x times differentiate tangent, you get secant square x. Okay, good. Then from there, you distribute a 2, you get 2 tangent x plus 2x secant square x. Good. Then from there, you got derivative of this guy equals to this guy. You can integrate both sides. So you need to integrate a tangent x, right? That's what you're asking me?
Yes. Yeah.
Okay.
How do you integrate tangent? I know. Wait, isn't it if you like integrate what secant square x, you get tangent x? Wait.
Correct.
Okay. Yeah.
Sorry, this one might be a mistake of the question. Integral of tangent x involves ln of something. Let me just get up the formula list. MF26. This might be A levels already, but then let me see. Could you derive this on your own without? Yeah, I'm sorry. Yes, this one requires a extra part. Requires an extra part. Okay, let's. Okay, not bonus. This one is required. Find the derivative of ln of secant x. Let's do it together. So let me add a new page. Okay, differentiate ln of secant x. This means that you need to differentiate ln, you get 1 over secant x. Then after that, you differentiate secant x, right? Okay. So how do you differentiate secant x? What is secant x?
Secant x is 1 over cosine x.
Good. So you can also rewrite it as cosine x to the power of
-1.
Okay. So how do you differentiate secant x? Now it's equivalent to differentiating cos x power -1. Okay. How to differentiate power -1?
D inside. So cosine
D
x
outer.
becomes.
Wait. D outer times D inner. Outer is the power -1, the yellow one. Inner is cos x. Chain rule asks you to D outer times D inner.
Cosine x. Wait, ln cosine. Wait. Ln cosine x times -sin x.
No. You're confusing integral with derivative.
Oh my gosh, I'm so confused.
Integrate x power -1 dx, you get ln x. Now we are just differentiating. Power rule. Doesn't matter if it's power -1, it's okay. Bring down O power, -1, get the u. Okay.
-1
times. What's inside? Is it just x?
cosine x.
Oh, it's just cosine x. Okay, good. Then what happens? Power rule. Differentiate x power n. You get n times x power n minus 1, right?
Oh,
n can be
negative
any.
2.
Negative 2, yes. That's
Oh,
a d outer.
brain
Chain rule.
times negative sine x.
Yes, negative sine x. Okay.
Oh
Now
my
let's
God.
try and clean this up. Let's clean this up. 1 over secant x is actually 1 over cosine. Secant is 1 over cosine, so 1 over secant is actually cosine x itself, right? Okay, why is the don't freeze? Okay, cosine x, right? So the rest, let's calculate.
X.
Minus cancel away, become positive.
Tangent x.
The cosine x squared goes to the bottom. The sine x goes on top. What cancels away? Cosine x cancels away, one copy. You're left with sine x on top, cos x below, which is equal to?
Tangent x.
Oh, so conclusion, derivative of the ln of secant x equals to tangent x. Therefore, if you integrate both sides, integral of tangent x equals to, sorry, I forgot the dx. dx equals to
is ln secant x.
very good. Yes, ln secant x. But there's a condition, which is that the modulus x must be less than pi over 2. If not, the function is undefined. Secant x is like 1 over cosine x, right? So if you have cosine x equal to 0, you end up with 1 divided by 0. We don't want to have that, right? We don't want divided by 0. So that's why your x must be within pi over 2 to negative pi over 2. Sorry, cosine graph. Within here. Okay, before the cosine x hits a 0, which means you will get a division by 0, we try to avoid that. So we say modulus x less than pi over 2. In other words, negative pi over 2 less than x less than pi over 2. There's a restriction on the values of x. Is that okay?
Okay.
Yeah. But anyways, you don't have to stress about that. Let's just assume that the x values are always such that the function is defined. So integral tangent x is just ln secant x. Okay? This is extra knowledge. I'm sorry. You are supposed to have this knowledge before you can solve this question. Yes. Okay, then from there, you continue 2x tangent x minus 2 times of integral tangent x, which happens to be ln of secant x. Dx, sorry, no more dx, plus c, and then we are done. Is that okay? Good. So 2x secant square x. Yeah. And hence show that the integral, the definite integral from 0 to pi over 3 of this guy equals to 2 root 3 over 3 times pi minus 1/4. Okay. So now you need to sub in pi over 3 and 0. So let's quickly do that. Yeah, so this guy, copy and paste, but then you replace the upper lower limit with 0 pi over 3. Sorry, pi over 3 and 0 respectively. So that means you get 2 times pi over 3 times the tangent of pi over 3 minus away 2 times the ln of secant x, which is 1 over cosine of pi over 3. That's the first part. Minus away, sub in with 0. You get 0 minus 2 times ln of secant 0. What's secant 0? What is secant 0?
1 over cosine 0, which is 1. Isn't it 1?
Secant 0 is 1 over cosine
1.
0. Yes, 1 over 1, which is 1. So what's ln of secant 0?
Ln 1. Wait.
Yep, ln 1, which is?
1.
What's ln 1? Oh no.
I mean 0. I mean 0.
Yes, it's a 0, so it's 0. Okay, so this is actually 0. 2 times 0 is?
0.
0. So 0 minus 0, the whole thing disappears. Okay, how about cosine pi over 3? It's cosine 60 degrees. 1/2. This is 1/2. 1 over half is 2. So ln 2. Ln 2. Good. Minus away 2 times ln 2. Then you have 2 pi over 3 multiplied by tangent pi over 3. Tangent 60 is root 3. Okay. Exact value. Hopefully you can remember. If not, never mind. You can always type in a calculator and you got your answer already. 2 root 3 over 3 times pi minus ln 4. 2 root 3 over 3. 2 root 3 over 3 times pi minus ln 4. Okay, just to modify it a bit more, this 2 can go up over here as a power, right? But change it to a small power, then we get ln 4. 2 root 3 over 3 times pi minus ln 4. Is that okay? Okay, good. That is this part. Wow, running out of time. Let's see, question 34. So over here, we got the derivative of 2x times square root 3x minus 2 equals 9x minus 4 over square root 3x minus 2. You are supposed to show it. Let me see your working. Factor out 2. Differentiate this guy. Product rule. Differentiate the x to get 1. Keep the other guy. Plus, keep the other x. Differentiate square root. So differentiate square root means what? 3x minus 2 power 1/2. You differentiate this, you get you bring down the whole power minus 1. So you get half times 3x minus 2 to the power of -1/2, and then you times 3. Here, the power -1/2 means you can bring it down. So it becomes 3 on top. You're missing a 2 here. Right? You have this bracket. You're missing a 2 here. Bring down, right? Because you bring down the half. Yeah, so do it step by step. Safer. Bring down the whole power minus 1 to get the new power. Half minus 1 to get -1/2. Then 3x minus 2 differentiate, you get 3. Okay, then distribute the 2 into the first and the second term. For the second term, 2 will cancel away. So lucky for you, the 2 cancel away. So you're still safe. Correct, wrong, then correct again. 2 mistakes cancel each other off. Okay, very good. Very bad. I don't know. This one, 2 goes in the first one, 2 goes in the second one. Technically, you should have had an extra factor of 2, but you forgot to do that. So your second mistake helped to correct your first mistake.
Wait, is it? Wait, how do you know it's not just me? Because it's 2 separate. Oh, okay.
Yeah, it's 2 separate terms. The 2 should distribute into both of them. But you didn't put a 2 in the first place. So this should have been a 6. But okay, never mind. It's all right. We can move on. Now you have this over 1. So it means that you need to make sure the denominator is the same. How do you do that? Multiply top and bottom by square root 3x minus 2. So you end up with 2 times square root 3x minus 2 times square root 3x minus 2. Cancel away, you're left with just 3x minus 2. Plus a 3x. Good. So this becomes 6x minus 4 plus 3x. Become 9x minus 4 over root 3x minus 2. Very good. Shown. Part B. Show diagram shows part of the curve y equals 9x minus 4 over square root 3x minus 2, and the line x equals to 20. A line passing through the origin O with gradient 25 over 12 intersects the point at the intersects the curve at the point A, where the x coordinate is 6. Okay, good. So here there is a rather funny looking curve going on here. That's due to the graph having the graphing software having some problems with displaying the graph exactly. So maybe it's better if I show you the actual curve. Give me a second. Okay. Here. Can you see the shared screen? Can okay, let me show you the function. This is y equals to 9x minus 4 divided by square root of 3x minus 2. Okay, so this is how the curve actually looks. Can you see? It goes down and makes a very sharp turning point, and then it goes back up. So that's what the graph is trying to do. Let me go back to the screen. Right, so that's what the graph is trying to show you here. It goes down and it goes up. Okay, it's not actually so sharp. It's actually a curve. It's actually a smooth curve like this. Sorry, more like this. Okay, like this. But then it became a sharp point because of the printing error. Okay, so anyways, what happened? You have a line that passes through origin with gradient 25/12, and it passes through the point A. So question, is this a tangent line?
No.
No, tangent line must be outside the curve. So for example, like this, your tangent lines must be here, 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 here. Okay, this guy is this line here is not a tangent line. It's a line that looks like this. Here's the origin. Here's a point A. Okay. Can good. So x coordinate is 6. Okay, now finally find the y coordinate of A. Just sub in x equal to 6 into the function. This guy. Now sub in x equal to 6. If you sub in x equal to 6, what do you get? Let's see. So for part 1, you get y equal to 25/2. Okay, good. Hold on, wait. That's not exactly it. You already found 25/12. Okay, that's also correct. Yes, yes, yes. An alternative to this is you can also sub into the original function itself. Does it make sense? Because it's the common point.
But isn't that harder?
Okay, true. Yes, actually harder. But yeah, so your method is the most efficient. Okay. Very good. Yeah. In case you want to do that. Okay, not recommended, right? Okay, never mind. Move on. Part 2, determine the area of the shaded region bounded by the curve and the line x equals to 20. The line x equals 20, the x-axis, and the line OA. Yes, very good. You split it correctly. So what you notice is that in A1, the upper function is a straight line, lower function is also a straight line. But for A2, the upper function is the curve, lower function is the straight line, the x-axis. So upper minus lower, get the A1. Integrate from 0 to 6. Then integrate from 6 to 20, the upper minus the lower. And then you add them together, you get your answer. Let's see if your setup is okay. A1 equals to upper minus lower. But actually it's a right angled triangle. So you don't really need it. You just need half times base times height. Half times 6 times 25/2. Okay, good. Can. Then next one is A2. A2, you want to integrate from 6 to 20 of the function 9x minus 4 over square root 3x minus 2. So over here, yes, we already figured out that derivative of whatever gave you 9x minus 4 over square root 3x minus 2, which is the integral here. So integration is the reverse of differentiation. So that's why you can work backwards and get back to 2x times square root 3x minus 2 here. Sub in the upper limit and lower limit, 20 and 6, and you get your answer here. Okay, actually, let me just double check. 2 times. Okay, 2 times 20 times square root, 3 times 20 minus 2. This becomes 304. Then you subtract away. This time is 6. 2 times 6 times square root 3 times 6 minus 2. And I get 256.63. Okay, good. Can. Then after that, you get the sum and you get your answer. Okay, I will believe this is correct. Just add a 35, right? 37.5. Okay, good. Next one. 35. Differentiate 2 sin x over 3 minus 2 cos x can be expressed in the form of something. A and B are constants. Part 1, state the value of A and of B. Okay, so over here you have 2 times something. So you just factor it out first. Good. Factor out already, then you have to differentiate a quotient. So bottom the top minus top, the bottom whole thing divided by bottom square. So bottom is 3 minus 2 cos x. Differentiate sin x, you get cos x. Sin x is there, then differentiate 3 minus cos 2x, you get negative sorry, what do you get? Let me see. Differentiate the 3, you get a 0. Differentiate negative 2 cos x, you get negative 2 times negative sine x, which is positive 2 sine x. Okay, good. And just carry on. So now you have a factor of 2. You multiply in, you get 6 minus 4 cos x times the cos x minus here. Oh, sorry. Right, there's an invisible pair of square brackets. The 2 goes in the first term, then the second term. So once you go in, you get 6 minus 4. Once you go in the second guy, you get 2 times 2, which is 4. So minus 4 sine square x over 3 minus 2 cos x bracket square. Good. Now multiply the cos x into the first two. You get 6 cos x minus 4 cos square x minus 4 sine square x. The minus 4 cos square minus 4 sine square, you can factor out negative 4. You get sine square plus cos square x. And they cancel off, become a 1. You're left with negative 4. Good. So 6 cos x minus 4 over 3 minus 2 cos x bracket square. So comparing with the form above, we realize we need a cos x plus b on the numerator. So that means a equal to 6, b equal to negative 4. Good. Okay, for part 1, that's done. Let's look at part 2. Evaluate the integral from 0 to pi over 2 of that monster expression. Wow, so scary. But don't worry, because it's very, very close to whatever you just found before. It's just off by a factor of what? Off by a factor of 2, right? 3 cos x minus 2. This is 6 and 4. Okay, so you just need to divide by 2 on both sides. Maybe I can present it neatly like this. Differentiate 2 sine x over 3 minus 2 cos x equals to 6 cos x minus 4 over blah, blah, blah. Here, you can factor out a 2. This becomes 2 times 3 cos x minus 2. Then close the bracket like that. There's a factor 2 here and there. Then you can cancel off on both sides. Right? You can factor out first, then cancel. Okay, then maybe that's more accurate to do. It's more accurate to do that. Factor out the 2 first, then cancel. 2 on both sides. So that's how you get the sine x over 3 minus 2 cos x. Good. Sub in pi over 2 and 0 and get a 1/3. Okay, yes. Can. Okay. Very good. 35 done. Let's go to the next one. 36 to 40. Let's see. So you got question 36. Diagram shows part of the curve y equals to something, intersecting the y-axis at the point P and intersecting x-axis at the points Q and R. Point S lies on the curve and PS is parallel to the x-axis. Find the coordinates of P, Q, R, and S. Part 2, area bounded by the curve PQ and the coordinate axis, and then part 3, area of a shaded region. Okay, let's go. So you have equation 1. For point P, you sub in x equals 0, you get y equal to 3. Okay. Good. Then P is 0, 3. Good. So now you sub y equal to 0 into 1 to get the points R and R and Q. Right? So sub in 0, you get 4 minus fraction equals 0. Bring over, you get this equal 4. Bring over, you get this, divide by 4. Okay. A plus b bracket square, 2x bracket square is 4x square, plus 2 times 2x times 3, which is 12x, plus 3 square is 9. Then you bring the 9 over 4 over. So 9 minus 9 over 4 is, let's see, 9 minus 9 over 4 happens to be 6.75, which is 27 over 4. Okay. Then from there, you solve in a calculator the quadratic. 4, 12, 27 over 4. You get negative 3/4 and negative 9 over 4. Good. Yes. Then negative 9 is bigger, is more negative, so that's why it's a point R. Negative 3 is over here on the numerator. Negative 3 is a bit more positive than negative 9. So therefore it is point Q. Okay, good. 0, question mark, this is 3. Good. So moving on, what we have now is the points already of P, Q, and R. What's missing? We're still missing a point. What point? Mic test, are you still there?
Yeah.
Okay, what point are we missing now?
Yes.
You got P, Q, and R already. So now it's just S. Okay, S lies along y equal to 3, right? Okay, so we just sub in y equal to 3 into equation 1. So we get 3 equals to 4 minus 9 over something square. Okay, then from there you can subtract the 4, you get -1. Divide by -1 on both sides, 1 equals 9 over. Cross multiply, you get this. Square root both sides. Oh, sorry, no, you expanded and then you subtract away a 9 on both sides. Okay, can. Good. Factor out the x, you get x times 4x plus 12 equals 0. Divide by 4 on both sides, you get 1, 3. Then 1x plus 3, so you bring the 3 over, you get -3. Good. Then you end up with -3, 3. Good. That's point S. Then part 2, the area bounded by the curve PQ and the coordinate axis. Okay, let's see. Area bounded by the curve PQ and the coordinate axis. So it's basically the shaded region. Oh, hold on. It's basically a shaded region that you drew yourself over here. This part here. So how do you do that? A few different ways. I think the easiest way is to do it by dx. So we go from -3/4 to 0, integrate this guy. Is that what you did? -3/4 to 0, integrate this guy. Okay, good. So area equals this guy. So integrate 4, you get 4x. Integrate this guy power, bring up, become power -2. You just add 1, get the new power -1. Divide by the new power -1. And there's a coefficient 2, so you divide by 2 as well. So that means -1 times 2 gives you -2. Okay. Sub in the upper and lower limit, 0 and -3/4. This part, before you sub in, you simplify a bit. Let's see. Minus cancel. This goes down. You get 2 times 2x plus 3, which is 4x plus 6. Good. Then from there you get 3 over 2. Let's see. 9 over 6 first. Then you subtract away the other guy, but you sub in with -3/4. 4 times -3 over 4 plus 9 over 4 times -3 over 4 plus 6. So you end up with 3 over 2. Yes, good. So for part 3, the area of the shaded region. So how did you do it? 3 times 3 minus 3 over 2 times 2. Yes, by symmetry, is it? These two regions are equal.
Yeah.
Okay. Yes. Yes, correct. Okay. Can accept. Yes, they are symmetrical. Because the length here and the length there is the same. Okay, and also because of the symmetry. It's a power 2 even function. Okay, good. Moving on. So, 27, this one, circle, what happened?
Can do into the partial fractions part, but then don't know how to differentiate don't know how to integrate the 5x over 2x squared plus 3.
Okay.
It's
Let me
like
just go through this. This one also maybe a little bit outside. They should have gave you a part 1 before you do this part 2. But the idea here is that if you have a derivative, like let's say, let me think of something. How should I put it? Let's say you start off by differentiating this guy. Ln of 2x squared plus 3. What do you get?
you will get 1 over 2x squared plus 3.
Not just that, you have to times chain rule
x
times 4x, right? Because of the derivative. So in other words, if this was ln of f of x, you differentiate this, what do you get? 1 over
1 over fx
f of x
times f apostrophe x.
Yes, f prime x. Okay, so in other words, the derivative of ln f of x equals to f prime x over f of x. Okay, this is a very special identity that's actually only taught in A levels. Oh, H2 math. But anyways, when you differentiate ln of that function equals f prime over f, that means the integral of f prime x over f of x dx will give you back ln of f of x. Agree? Asi?
No,
No, don't agree?
agree.
Okay, so it's basically the same idea as this guy here with an actual example. Okay, if this equals to 4x over 2x squared plus 3, that means that integral of 4x over 2x squared plus 3 dx gives you ln of 2x squared plus 3. Okay, plus it. Right? And the key idea here is that the top numerator is the derivative of the denominator. Differentiate 2x squared plus 3, you get 4x. Right, so if there's a derivative on top and there's the original at the denominator, you integrate this whole thing, you get to ln of the denominator. Okay? Is it clear?
Yep.
Okay, so over here, what's the derivative of 2x squared? What's the derivative of 2x squared?
4x.
4x. So over here, we got a 5x. So that means that we are slightly off. How do you get the answer to integral of 5x over 2x squared plus 3 now? Times how much?
5 over 4.
Very good. Times 5 over 4. So that means the answer must be 5 over 4 ln 2x squared plus 3. Okay. So 5 over 4 ln 2x squared plus 3. Sorry, technically should have modulus here. Modulus. Okay. Then after that, sub in the 0 to x equals. Can?
Mhm.
Okay, let me just shrink down this working. Shrink it down like this. Okay, can. Yeah, so x equal 2, x equals 0. Can. And then I will leave you to substitute on your own. Okay?
Mhm.
Yeah. Just need to remember ln A plus ln B equals to ln AB. Multiplying. Addition becomes multiplication. So you can do something similar here, even though there's a modulus sign. Like, for example, modulus, modulus, modulus. Okay, still the same. Okay, I don't confuse you with the modulus. I'll just put the normal version. Ln A plus ln B equals ln AB. Okay, okay.
Mhm.
You can use this identity here to simplify the final answer. But if you want to, not require in this question. Okay, next one. Whew. Question 38. Okay, I might not have enough time. I need to end sooner. Let me see. Maybe I go to the ones that you don't know. Negative value wrong. Okay. How about this one? Okay, I'll mark it and return you later. Let's go to the ones you got wrong first. Question 39. The diagram shows a region bounded by the curve x equals y minus 2 bracket square and the line x equal to 2. Calculate the area of the shaded region. Sub x equal to 2 into this guy. 2 equals bracket y minus 2 bracket square. Expand y square minus 4x plus 4. Bring the 2 over, you get y square minus 4x plus 2 equals 0. Solve, you get the two values truncated. Good. Okay. Let me just double check with the calculator first. It's one slight mistake here. Should be a y, not x. Right? Can only have one variable. So here you get 3.414 and 0.55. Yep, good. So how do you find the area of this shaded region? You have to integrate dy, right? Because that will be easier because you can go from bottom to the top. Let's see. That actually will only work to find the area here and there, the red color region, because it's always like this. Y equals to A, Y equals to B. That's an area over here. That area is equals to, if this is x equals f of y, integral of f of y dy from y equals to A to y equals to B. Okay, maybe I call this G. G. Okay. You get the area to the left of the curve. To the left of the curve, but to the right of the y-axis. So here, you will actually end up finding the area of these two red regions when you integrate from 0.58 to 3.414, if I'm not mistaken. Yeah. This lower value is y equals 0.58578. The upper value is y equals to 3.4142. Okay. Oh, negative value. Let's see. Let's see. That's not supposed to happen. Unless I interpret wrongly. Let me think. X equals y squared minus 4y plus 4. You integrate this from 0.58 to 3.414. That will be subbing in the 3.414 and the 0.58. This should give you a positive value. Do you sub in wrongly? I'm not sure. Let me see. Hold on, I'm typing the answer right now. Okay, this you got 1.88. I think you typed it wrongly. Yeah, I think you typed in wrongly. It's I got 1.885.
Oh.
56. Okay. But is this the answer? No, because you want the shaded region. What the 1.885 represents is the red color region. So what do you do to find the shaded region? What shape is this?
Curve.
No. The green color box.
Rectangle.
Rectangle, yes. So how do you find the gray shaded region given that you know the red color region?
Point of
Minus. What minus what? What we just found was the area of the red region. We want the shaded region. How do we find the shaded region? What minus what? Hello?
Yeah.
How to find? What minus what? Sorry, are you saying something? Mic test, can you hear me? I cannot hear you. Oh, I cannot hear you. But I can, okay, you can hear me, but I can't hear you. Uh-huh.
Hello.
Hello. Oh, I can hear you now. A bit soft.
Oh,
I can hear you now. Yes. Can you hear me?
yeah.
Okay. So how? What minus what? How do you find a shaded region?
Rectangle minus unshaded.
Area of rectangle minus away the unshaded part. Yeah, but in this case, of course, the unshaded part is the red color, red region. Okay, good. Can. So yeah, so how do you find the area of this rectangle? It's really just finding the height here and the breadth here. It's 2 here and 3.414 minus 0.585. So let's calculate this. 3.4142 minus 0.58578. Let's see what that value is. Minus you end up with what is it? 2.82842. Right? Good. And therefore area of the rectangle is actually 2.82842 multiplied by our 2. You actually end up with 5.65684. Minus away the unshaded region, which was whatever was the answer from below. So just to get the complete answer, your final answer will be area shaded, handwriting, equals to the total area of the rectangle minus away 1.8856. Is that okay?
Mm-hmm.
Then just round off to 3SF and your answer is done. I think over here you just type in wrongly because I managed to get a positive. I just submit. Okay, can. Yeah. So last question. Okay. Let's see. Diagram below shows parts of the curve y equal to cos x and y equal to cos half x. So where is my cos x? It's here. Cos half x is over there. Yeah. So the line x equals to pi over 3 meets the curve y equal to cos half x at point A, and the x-axis at B. The tangent to the curve at point A meets the y-axis at C. Find the exact length of BC. So BC, that just means we need the coordinates of B and the coordinates of C. Can you tell me what's the coordinates of B straight away?
X is pi over 3 and y unknown.
0, right? Because it's on the x-axis, so it's a 0.
Oh, wow, okay.
Okay. How about C? Same thing, huh? The y-axis also
0.
0. But what's the x? This one needs a bit of work. You first need the equation of this line, then you create y equal to 0. Then solve for x. But how do you find this equation of the line? What kind of line is this?
Tangent to the grade. Oh my god. Tangent to the curve.
Tangent line LAC. Good. So how do you find tangent line LAC? What are the 2 ingredients you need?
Is it half? Is it minus half sine x?
Minus half. Minus half sine x. Oh, did you differentiate cos half x? Yes.
Is it? No.
Yeah, that will be the gradient function. That's not a gradient. Tell me again, for a straight line, what are the 2 ingredients you need? The toot formula. The toot
Point slope.
point and a slope. Exactly, you got it. So first you need a point on the a point that is on the line LAC, and then you need the slope, the gradient. Here you differentiate. Oops, you realize that it is a tangent line at the point A, right? So differentiate cos, you get negative sign, copy and paste the base, then differentiate the inner, you end up with a half. So what I just did was chain rule. Huh? This is the outer, differentiate the outer function, cosine function, then differentiate the inner function, which is the half x. Outer function is cosine, inner function is sine. Inner function is half x. Okay? Good. So now that we have this, we also know that this point A line, what was that? This point A has a point x equals pi over 3, correct? Right? Mic test, am I still connected?
Yeah.
Yes, huh?
Yeah.
Okay. So x equals pi over 3, right? So that means you actually need to sub x equals pi over 3. What do you get as dy by dx then? Must be negative sign, half times pi over 3, and then times half, correct? Very good. So that means you're left with negative half times the sine of pi over 6. Wait, what's pi over 6? 30 degrees. Sine 30 degrees is? Sine 30. Calculator. Okay. Yeah, that's oh no. Other way around, 60 and 30.
Cause equilateral.
Yes.
Cut in half.
Yes.
Right. So 4 is 2, 1 square root 3. Then sine 30 half.
Half, exactly. So therefore it's a half. Negative 1/4. That is the m gradient of AC. Is that clear?
Yeah.
So we got the slope already of the 50% of the work done, point slope formula. Okay, 50%. Close enough. Then after that, now you need the point, which is a point. We know it's point A is pi over 3, comma, what is it? Something, right? We haven't found the something. So what do you do now? Sub
Pi over x equals pi over 3
into
the cosine half. Wait, y equals cosine half x.
very good. Don't sub into the wrong function. It's cosine half x, not cosine x. Okay, so we're gonna sub in and we end up with y equals cosine of half times x, which is cosine of pi over 6, 30 degrees. Cosine 30 is sine 60, which is root 3 over 2. Can?
Yeah.
Okay, just have to recall. So root 3 over 2, now that we have a point, which is pi over 3, comma root 3 over 2, we can now figure out the equation of the line LAC. Okay, so what does it become? It becomes y minus away the y coordinate equals to m, the negative 1/4, times x minus the x coordinate. Pi over 3. Point slope formula. Okay so far?
Yep.
With the point slope formula obtained, with using the point slope formula, we obtain the equation of the line LAC. But we need the point C. So how? Sub in.
Y equals 0.
Okay, very good. So over here, we sub y equal to 0, and then we are able to solve for C. So 0 minus root 3 over 2 equals negative 1/4 x minus pi over 3. From there, you can solve for x. So let's times a negative 1/4 over, negative 4 over. So we end up with positive 4 times root 3 over 2 times just x minus pi over 3 on the right hand side. Good. 4 and 2 cancels away, you're left with 2 root 3 equals to this guy, x minus pi over 3. Solving, you get x equals 2 root 3 plus pi over 3. Okay? Can? 2 root 3 plus pi over 3?
Yeah.
Can, Okay. That also means that your point C will be 2 root 3 plus pi over 3, comma 0. Can? Rewrite my 3 more need 3. Okay, good. So transfer that information in the diagram. 2 root 3 plus, ayo, no space. Bring over. Pi over 3, comma 0. Very good. Now can you find the length BC?
Yes. BC is 2 pi over 3.
You mean square root? 2 root 3.
I mean, yeah, I mean square 2 root 3.
Yes. Okay. Very good. That is part 1 done. Wow, still not done. Part 2. The exact area of the shaded region, leaving your answer in third form. Can you just take upper minus lower? Like let's say, oh, this one is upper, this one is lower. You just minus.
No.
No, you must look carefully from scan
Wish
from
you
left to right.
could. I wish you could.
Yeah, it's not that simple. But maybe there was a simpler way. There's a simpler way. Wow, do you need to really like one new suggestion to do this is split it up in all these different intervals. Like, oh wait, actually no. This one, point A here, then after that is a straight line. So maybe you have to go and find this triangle, right angle area first. Then you find this tiny white color unshaded region, subtract,
Oh,
then you get this
no.
region.
Oh, no,
And then
no,
after
no.
that, this part here, you integrate
Fine.
upper minus lower. No, is there a faster way?
Wait, now I'm confused. Wait, this is not a straight line here. This is not a straight line one.
Yeah,
Right.
no, it's curved. Yeah, so
Yeah, only here is a straight line.
correct. So actually what I suggested is probably the only correct way. What did I just say?
I must find the. Okay. Oh, okay. Okay.
How?
There are like a lot of ways to do.
Yeah.
Yeah.
So what do you recommend?
Oh my gosh.
Last question of the day. Last question of the day.
I mean,
Okay.
okay. Oh, wait, no. Oh my gosh. Okay, find this. And then you find oh my gosh.
A2, okay. And understand. The tiny little shaded region there.
So you find A1 by itself. Then you find the total ABC triangle. Then ABC minus A2 give you A3.
Did you mean minus A3 to give you A2?
I mean, yeah, that's what I mean. That's what I mean.
Okay. So that's good. That's a good strategy. I'll follow that. This region is A1. This region is A3. Then after that, this remaining region over there is A2. Let's see. So integrate from 0 to pi over 3 of cos of x. Good. Minus away, who's the lower function? It's actually cosine x. It wasn't labeled.
How do you know?
Oh,
How do
because
you
they tell us shows parts of the curves y equal cos x and y equal cos
Oh
of
my
x.
gosh, okay.
They just didn't label.
Yeah, so this is A1.
Good. Yeah,
And
I'm sure you know how to work it out.
triangle ABC is half times length BC, so half this, and then AB coordinate A. Just now we found it.
Let's see. Do we find it just now? A is A. No, let me see. Yeah, A is this one.
Yeah.
Pi over 3 comma root 3
So
over
this
2.
triangle ABC.
Oh, yes, yes.
And A3 is from integral from and then cosine x dx. So take
Exactly.
BC minus A3 plus A1.
Yes, exactly. That's it. That's all. Very, very good.
Why math so hard?
But you got it. It's okay.
Okay.
Just need. It's just very long winded. Okay, and the more difficult part is this part over here. Give the exact area leaving answer in third form. So they want to see all the square roots. They want to see all your square root 3 over 2. Cannot use calculator.
No, can, but just square.
Okay, yeah.
Yeah, that's the strat.
Yeah. Okay.
Okay. Math so hard.
Is that a duck? I have no idea. Okay. Let me think. What is it? Okay. Can I give it's already 11. Okay. Let me think. All right. Let me do a quick crash course on kinematics.
Okay.
I know. Are you awake or are you very sleepy now?
I'm awake. I'm actually awake.
Okay, very good. Then I'm just gonna teach you the basics of kinematics. Okay, this is the last chapter. So, in kinematics, you're just basically taking distance, speed, and time, which is scalar, and upgrading it into vector. So now it becomes S, V, and A. Okay, actually this is not accurate anymore. Sorry. This is more like instead of we can't use the triangle anymore. Sorry, no more triangle. We introduced 3 different letters. It's called S, V, and A. Okay, what do they stand for?
Velocity, acceleration,
Yes.
displacement.
Very good. The reason why we use S here is because
why is it S?
because the previous 2 letters are already resolved.
Oh, okay.
Okay. So what is the key relationship we need to understand here is that let's start with, for example, the case where it's scalar. If this was distance, like let's say you are measuring the distance moved by by a bus with respect to time, it could be like this. It goes up like this, and then it stays there for a while and doesn't move, and then it goes back down like this. How do you find out its speed? Here is how you find it, right? If let's say you look at this first half, maybe this one is say, 100 km. Okay, I don't put the distance. This is units in km. This is units in, hours. Then this is like, maybe after 2 hours. Okay, so what's the average speed for this yellow color region?
Then wait.
Speed
Average
for the yellow.
100 over 2.
Exactly, that's it. As simple as that, right? So you get 50 km per hour. But another way to interpret it is you're actually drawing a tangent line on this curve and you're finding the gradient of the tangent. Does that make sense?
Okay.
This guy is the gradient of the tangent. But now with vectors, what we are simply doing is we are changing the y-axis here to something called displacement represented by the symbol S. Okay, here, right? Against time. And then we try to figure out the, oh, by the way, displacement can be negative now. Let's say you have a sine curve. Okay, what this means is you are pretend that you imagine this scenario. You have a box here. We call this a particle, or just a ball. Let's make it simpler. The particle now will move to the left and towards the right along a same straight line. Along the same straight line. It cannot move up and down. It cannot move diagonally. Okay. This is the topic in AMAX called 2D kinematics. Because it can only move to the left and to the right, two directions, two-dimensional. Sorry. No. This is not 2D, this is 1D. One-dimensional. Move in two different directions, but only along one line. So it's one-dimensional kinematics. For 2D kinematics, it will be involving the other axis, the y-axis, so you can move up and down and diagonally. 3D, then you have to go forwards and backwards out of the paper already. Okay. For now, we will only focus on 1D, meaning that a particle moves along a straight line. Or it could be like an MRT train that's moving left and right, towards the east, towards the west, towards north, towards the south. Okay. Two directions only. So here we are saying that displacement upgrades from distance because it now can become negative and it can even be zero. So think of it like this. When this goes up, it's a positive y value, right? Then that means that the particle moves towards the right. And then eventually it just drops back down until it becomes zero, means that it goes towards the right and then eventually it goes back to its original location. Then from here, when it goes negative, it means you move towards the left. And then eventually, when it goes back to zero, it means that you move back to your original location. Does that make sense?
Yeah.
Okay, good. So now, in order to find what's known as velocity, the next idea here, all you need to do is to find the gradient of a tangent line. This is what we call the gradient of this tangent line is equals to the instantaneous velocity. Meaning at only one single point in time, you want to find out its vector version of speed. The vector version of speed. Oh, but sorry, I forgot to mention the units to you. The physics units for displacement in this case is meters. For velocity is meters per second. Acceleration is meter per second square. So meter per second per second. Did you learn this before in science?
I think so.
Yeah. And those who took physics will know this. But this is the math version. We go a little bit more in detail. So here, gradient of tangent line will become the instantaneous velocity. Okay. So now if you upgrade the graph now to change the y-axis into velocity. Okay. So in this case, it becomes like this because you differentiate sine, you get cosine, right? Why do I differentiate? Because we are looking for gradient of tangent line. Does it make sense so far?
Yeah.
Okay. And it kind of makes sense why you want a gradient because you see, gradient means what? You draw a right angle triangle, you calculate rise over run. How do you get the rise? It's really just the two y values, right? Then how do you get a run? It's the x1 minus x2. But in this case, x1 minus x2 is like time. So this unit is, let's say the units here is, I don't know, seconds. The units here, let's say, is meters. Then this will be in seconds. Whereas for the y, it will be in meters. Okay.
Mm.
And so if you take meters divided by seconds, what do you get?
M over.
M/s, meter per second, which is exactly the units for velocity. Right?
Mm.
Okay. Yeah, so the units check out. The units checks out. Okay. So anyways, after you change the y-axis to velocity this time and the x-axis still remains as time, this time you take the gradient again. What do you get this time?
Mm.
The answer is you have another rise over run. But this time velocity units is meter per second, time is seconds. Yes, exactly. You get meter per second divided by second, which becomes meter per second squared, also known as the acceleration. Okay. Acceleration will tell you there's a few physics interpretations, but for now, today, let's talk about that another day. Today, I'll just tell you the simple formula you need to know. To go from S to V to A, you do the following. Differentiate with respect to time, differentiate with respect to time. Why differentiate? Because you're trying to find the gradient of a tangent line. Right, using these two ideas, gradient of the tangent line. Gradient of the tangent of displacement graph gives you instantaneous velocity. Gradient of the tangent line of a velocity graph gives you acceleration. Is that okay?
Mm-hmm.
Right. Rate of, or in other words, the rate of change of distance with respect to time gives you velocity. The rate of change of the velocity with respect to time gives you acceleration. Okay, good. So how do you work backwards then? What is the reverse of differentiation?
Integration.
Integration, yes. That's why this is the last topic. It's an application of differentiation and integration. Integrate whatever. dt, and this one is integrate whatever dt. Here, the whatever should be input, then output. So that means that this should be a. Maybe I'll write down a here. Then input is v, output is s. Okay, so you integrate v, then you get s. Okay. Then the rest of the questions is all just applications of differentiation and integration, where you just have to practice differentiation and integration for the s, the v, and the a. Okay, majority of the basic type of questions. Later on, then you have to start to interpret what it means in terms of physics, in terms of the real world application. Some of such examples, which I will explain more in detail next lesson, is that if v is more than 0, it means that you're moving rightwards. If v is less than 0, it means that you're moving leftwards. Okay, we standardize arbitrarily. Okay, just flip a coin and decide that rightwards today is gonna be positive for v more than 0 for when we look at v. And leftwards means that v will be less than 0, negative. Okay, just like the number line on the x-axis. Okay, right is big, left is small. I mean, who decided on that? It's totally arbitrary. It could have been the other way around, but we just have to decide on one convention. Okay, so the convention is like this. I'll talk more about it next time. Okay, then I'll give you some practice questions on finding S, V, and A. Just very simple and differentiate and integrate to test whether you remember this idea. To go from S to V, you differentiate. To go from V to A, you differentiate. To work backwards, to go from A to V, you integrate. To go from V to S, you integrate. Okay?
Mm-hmm.
Yeah, that's all for today.
Okay.
Yeah.
Math very hard.
Yeah, this one physics, a little bit of physics. That's all for today.
Okay.
Bye-bye.
Thanks.
I'll send you the homework later.
Okay. Good night.
Good night. Good night.